Welcome to the third episode in this playlist around using the Prusa slicer and Prusa 3D printers at Marrickville, and also applicable to others around the world too. So we've made the setup steps necessary to have the best orientation for printing with this item. We're now going to have a look at some of the settings for printing. When you're new to this, I would strongly encourage you to stay in the simple mode for printing, and then following that you could just need to change these settings in this part of the screen on the right here. Print settings changes the layer height, so 0.5 of a millimeter, 0.07 of a millimeter, 0.1 of a millimeter, so on and so forth. The thicker the layer heights, for example 0.3 of a millimeter, the quicker the 3D printer will be able to print your item. Some of these names also explain the speed settings that are done and the number of layers or perimeters that are used. So speed, for example, at 0.15 millimeters is going to be faster than the quality setting of 0.15 millimeters because the quality setting just moves slower when it's printing, designed to give you better quality. If you've got a final product, go for it. If you're just drafting, I'd probably select a speed setting. Drafting at this stage is my favorite because it's very, very fast. So I'm going to select draft. I'm then going to go through the filament and just double check that I've got a PLA selected. Prusa PLA to be exact, because this actually is a Prusa filament that I'm going to use. You may be using other ones such as ABS, PETG, or HEPS, depends. Finally, double checking that printer is selected the correct one. At this stage at Marrickville we only have the i3 Mark III's. Hopefully in the future we'll get some more. And then you've got these settings here called supports, infill, and brim. To explain, I'm going to actually slice this and then show you the differences. With no supports on, 0 brim, and 20% infill, a slice, once it's generated, looks like the following. You've got individual layers built up. At the bottom, contact layer, which is the one touching the surface, you'll notice that it only has the material of the product being printed stuck there. And underneath, where you have this overhang space, there is no supports in that area to keep that layer actually printing perfectly. And finally, to look at the infill, if we zoom down into the body of the part, you'll notice that the hexagonal infill, or rectilinear infill here, I should say, has quite a wide spacing because it's at 20%. For the most part, for this print, that will probably be perfectly fine for my purposes. The general rule of thumb with brim is that if you need it, it will then create a slight layer around the outside to expand the amount of surface and contact area on the bed for the first layer. In this case, because my item is so low to the ground and it has a very large surface area compared to height, I would not need this in my opinion and previous printing experience. With the infill, this is a low use, low tolerance part. It's not going to have much structural strain on it, and thus infill isn't that necessary, and in fact will just slow the printing process down again. So I'm going to leave that at 20%. I am going to change it up to 80% and show you what supports look like as well. So supports from build plate only, and it will work better if you select yes and slice now, looks like the following. Underneath, you'll notice that there's now been some support generated along the edge. It hasn't actually created support for these items in the middle, this surface in the middle, which is quite high up on the inside, because it believes that it will still be able to print that. You can adjust custom settings to change that if you have a technical and complicated print. But if Prusa probably thinks that's going to be okay, I'd probably go with that. The other thing to note that I just changed was the infill percentage. I changed it to 80%, and if you look now at the rectilinear structure, it is much more dense. And that is, exactly what you're changing. The amount of density of the infill went from 20 to 80%, so we'd expect that to be much more dense. I'm going to change that back to 20%. And with the supports, I'm going to go everywhere just to double check that there's not going to be a change in what it looks like. And there isn't in this case because there was nothing that had an overhang that was higher than the bottom layer of the part. If you had an item that had an overhang that maybe didn't have a clear area below it towards the bed of the machine, you may want supports everywhere so it builds supports off of the part that it's already printed. Once you've done that, you'll need to export your Gcode. To export your Gcode, you press the export button. You'll then want to save it into a SD card. My computer doesn't actually have an SD card reader in it, so I've had to borrow an SD card reader tool, which I plug this SD card into, and then that block goes into my printer itself. I would also point out the fact that when that happens, it will be then visible under this PC, and you'll normally find it under devices and drives. It'll just pop up. Most of these SD cards have been renamed as Marrickville Prusa printer cards. Some of them though do have odd names because students like to be cheeky. Preferably don't change them. It's not a big deal if you do. Click Save, and that code will then be saved onto that SD card. When you pull out the SD card, please make sure that it definitely says down the bottom left corner there, Gcode file exported. With a big Gcode, it takes a couple of seconds and up to maybe a minute even. So if you pull it out too early, basically it will not save all of the data onto the SD card, and or it may not be fully disconnected from reading and writing the data on this card, and therefore there will be a glitch in the print code when you try to print it. So that's just a top tip. Thanks for watching. The next video will go about how to actually insert and then select print from one of these SD cards on the Prusa printer. Cheers.